All right, let's take a look at the Chapter 2 review. So we've spent the last about day and a half to 2 days working on this objective, basically looking at domain and range of a relation, seeing if the relation is a function, also determining whether functions are discrete and continuous, and then lastly but not least, be able to write equations with function notation and be able to evaluate those. So we're going to take you through all of these objectives today in this review. So on the very first problem here, I'm just switching colors for a second, is it asks us to graph each of these equations on your calculator. So I'm going to show you how to do that on your calculator here today. So sorry, I thought I had switched colors. So sometimes it doesn't like me. It says use your standard window, sketch the graph of what you see. Then identify the domain and range of each graph. All right, so to sketch it on our calculator. So first and foremost, if I go to my calculator, I'm going to go to my y equals. And I'm going to graph this first equation. It says y equals x squared minus 3. So again, here's my x key, squared minus 3. Just type that in. And I go ahead and hit graph. Now, if you are not in the standard window, okay, hit your zoom key and select number 6. That's going to give you the standard window, pretty much somewhat the similar window that you have right here, or the graph paper that we give you here. So if you look at this, we have a shape of a parabola. We know that x squared graphs are shapes of parabolas. And in essence, this minus 3 causes the graph just to shift down 3 points. Okay, so I'm going to go down here, 3, and I can sketch my graph. Up 1 over 1, up 1, it goes over 3. It likes to go 1, 3, and on up 5. 2, 4, 5. Same thing in the other direction. So I get a sketch of my parabola. So now we're asked to calculate out the domain and range. Domain, remember that domain is all of your x values. So when I look here for my x values, x can be basically any number. So if it helps, go to your calculator and say, all right, look at this. X can be any number, negative, and if I go in the other direction, I'm getting values for x can be any number positive. I don't get any errors whatsoever right here in this y1 category. So my domain can be basically any real number. So how do we write that? Remember, we always use parentheses for infinity because we don't count because infinity goes on forever. So we say negative infinity to positive infinity. So x can be any negative number or any positive number. So now when I look at my range values, look at my y doesn't go past negative 3. It's the smallest, or we can say it's the lowest that it goes negative-wise. You can actually see here, right here on the calculator at 0, it's negative 3, and it never goes past that. So my y values are going from negative 3, and we use our bracket to say we're including it, to positive infinity. Positive infinity and parentheses. Again, remember we use parentheses, okay, anytime we use infinity and we don't want to include the point, and brackets when we do include the point. All right, so I'm going to do the same thing here now for example B. I'm going to go back to my calculator. I'm actually going to clear out that equation. So I'm going to type in the square root symbol this time, x minus 4. And notice how x minus 4 is underneath it. So go ahead and graph this. Ooh. And you can kind of see a half of a sideways parabola starting here at x equals 4. So 1, 2, 3, 4, with a sideways parabola over 1, up 1, over 1, and really up 3, I get an idea of what my graph here looks like. So now if I look at my domain, look at how x is starting here at 4 and going on in the positive direction, but never in the negative direction. And a lot of times if you look at your table, you'll start to see, look at this. You get errors at -2, -1, 1, 2, 3, but you finally get your first point at 4, and you can see that the values just keep on increasing. So as you scroll down there, you can see that it gets bigger and bigger and bigger. So my domain, in this case, is a bracket because I can include 4, it gives me 0, and it goes to positive infinity. Open circle. So now for my range on this one, look at how my y values actually start at 0 here. Okay, so even if I go back, first value I get for y is 0, and then it keeps on increasing and keeps on going to positive infinity. So my range, those are my y values, go from 0, including 0, to positive infinity. So again, just to note, I know I didn't write this on the other one for both of them. Domain is your x values. Range are your y values. What are the possible values the graph gives you for, I'll put a little s there, forgot the little s there, for the equation. All right, let's take a look at C. Ooh, negative x cubed plus 1. Get another cool looking graph here. I'll clear this graph, type in x, raise it to the third power, so I get x cubed. Whoops, I forgot the negative, so let me clear that out and start again. Negative x raised to the third power, okay, and then plus 1. Okay, so I'm going to hit graph. Ooh, look at that function right there. I get kind of a curly, it's like a half a parabola and then a half a parabola going down. So if I look at my table here, it might help me with graphing some of the points. But you'll actually start to see some of the patterns here. So here at when x is 0, I'm actually at 1. So as I go to 1, I'm actually at 0. And then at -2, or I'm sorry, +2, I'm at -7. 2, 4, 6, 7. If I go in the other direction, I'm at 2. Then I go off the chart here, way up here at 9, even off into my graph. So again, I'm just trying to sketch it accurately. Sometimes you can use your table to help yourself out. So right away, hopefully you notice in your table here, there didn't seem to be any restrictions whatsoever on x. So my domain goes from -infinity to positive infinity. My range, if you look at these, notice how there's no restrictions on the y's. In fact, it's getting really big, positive, and it's getting really big, negative. So my range is -infinity to positive infinity. Again, parentheses with infinities. All right, my last graph. So I'm going to go to my y equals, and I have the equation negative. So I'm going to have negative, whoops, not the subtraction sign, sorry, negative, parentheses, x minus 3, close parentheses, squared, okay, and then I'm adding 2. So I know it's a quantity squared, so I know it's going to be a parabola. And some of the things that you might realize, that you might remember from other classes on transformations, this moves it up 2, this moves it to the right 3, this causes it to open down. Go ahead and hit graph there, and look at that. I have a parabola that has moved from the origin 0, 0 up 2 to the right 3. That's where my top piece right here is actually located. You can see 2, 3. So it's going to go right and left and down 1. Then it likes to do the 3 and the 5 pattern. Okay. If you're still kind of curious where I'm getting these points, okay, one of the things that I'm doing also is I'm looking at my table. I'm just graphing those points. All right, sorry about that. I had to pause for a second. So just to regain my thought, another way of getting these points, I'm just looking at my table and I'm graphing. So you can see how I'm graphing 3, 2. And then you can see how when I go to 1, I'm at -2. And then, this is interesting, something's up. Negative graph. Okay, no, that was right, table. Okay, oh, there we go. Something was, that was interesting. It was like giving me a different table for some odd reason there. So at 1, I'm at -2, yep. So here, yep, here I am at 5, -2, okay. 6, -7. So I'm just getting a picture, again, of my parabola. So just like the other one, parabolas, you'll notice that there's usually no restriction on the x values. So -infinity to +infinity. But my range, notice how this one, the first one went from -3 up. This one is starting at 2 and going down. Okay? So this one makes it a little interesting because you're actually going from -infinity and stopping at 2. So you always have to start at negative and go to the positive when writing it. Even though you want to go 2 to -infinity, the way we write it is always negative first, then positive second. All right, so that takes care of domain and range part of this lesson. The next part is just some review of discrete versus continuous. Discrete, think of as points. Okay. Continuous, think that you can graph it using some sort of line or curve. So when I look at this one, A, the amount of money you earn, Y, based on the number of hours you work. Okay? I start to ask myself, can I work 6.5 hours, 8.5 hours, 6.25 hours? Okay? Many companies, if you work hourly, when you punch in and out, will actually pay you to the 100th of an hour. So that you can actually graph like a line. So I look at that as being continuous. Okay. Part B, the amount of revenue made based on the number of tickets sold. Here, X, you can't sell like a half a ticket, a third of a ticket, a quarter of a ticket. So when you're graphing this, you'd be like getting a value at 1 and at 2 and at 3, but you won't have anything here in between. So that is discrete. C, height of the tide on a typical day recorded each hour. Okay? So even though you're recording it each hour, you could be recording it every minute, every second, and such. So when we look at this particular, the height of the tide, okay, this one is continuous. Okay? Because you could actually connect those points and it makes sense to connect them and graph them. Okay? Even though the height might change from hour to hour, it will increase or decrease depending on where you are with the tide. The last one, the number of teachers at Hopkins High School each year from 2015 to 2018. So the number of teachers, we would be looking at each year separately. So it wouldn't necessarily make sense to look at how many teachers we had in 2015 and halfway through the school year. Okay? So that one we would consider to be discrete. Okay? All right, that takes care of the front page. Let's take a look at the back page. So the back page here now talks about this function notation. Remember that f of x is the same thing as saying y. The reason why we like having this notation because we know it's the y value, what the y value equals, in this case 3x squared minus 11. So whenever we put a number inside here, that's what we're going to substitute for x into the function. So when I look at number 3 here, f of negative 2, it equals 3. Replace the x with negative 2 squared minus 11. So then we just simplify. Negative 2 squared is 4. Remember, squaring negative numbers make positive. 3 times 4 is 12. 12 minus 11 is 1. So f of negative 2 is 1. We do the same thing for the second one. Now we're plugging in 3. F of 3 equals 3 times 3 squared minus 11. 3 squared is 9. 3 times 9 is 27. 27 minus 11 is 16. So f of 3 is 16. Ooh, now we have a value with a letter in it. You're still just replacing it. So you're just saying 3 times 4a quantity squared minus 11. So when we square and we have two values inside, we square them both. 4 squared is 16. A being squared is simply a squared. So now distribute. 3 times 16 is 48. We have a squared minus 11. These two terms don't have anything in common. So f of 4a equals 48 squared minus 11. All right, our last couple examples in the review puts a few things together for us. So for number 4 here it says, for each graph, graph the points or sketch the graph, determine the domain and range, so kind of like what we were doing at the beginning. Determine if the equation is a function. Okay, so we'll talk about doing that vertical line test and state whether the function is discrete or continuous. So you can see domain, range, function, not a function, discrete, continuous. So the first thing I'm going to do is I'm going to take this equation and put it in my calculator. So I'm going to type that in. So y equals, I'm going to clear out the previous one. Ooh, look at that. X raised to the 4th power, okay, minus 2x plus 5. So I'm going to get a graph of this. Let me just double check that equation. It just doesn't seem right. Oh, I forgot an x squared. I thought I forgot something. I knew it was supposed to look something different. I forgot the squared piece. My apologies. I'm going back in and double checking that. So make sure yours has this middle part being x squared. Whew. Now when I graph it, now I'm starting to see a little bit more of what my graph looks like. So it kind of looks like a W here. So if I look here, 1, 2, 3, 4, 5. So I'm going to go to my table here. So notice here at 0, 5, 1, 2, 3, 4, 5, I'm going to put a point. At negative 1, it drops to 4, and positive 1, it drops to 4. Then all of a sudden at 2, it's at 13. 1, 2, 3, 4, 5, 6, 8, 9, 10. So 13 way up here. So I'm actually estimating it. So you can see if I go back to my graph here for a second, I kind of get this W looking thing. So I'm just going to kind of do a little curve and a curve up really quick and a curve up really quick. So I got a sketch of my graph. Domain, again, can't emphasize enough. X's, what can X be? Well, with this graph, when I look at that table again, X could be anything. Okay? X is positive and negative, so negative infinity to positive infinity. The range, however, never drops down less than 4. So my range actually starts at 4 and it goes up in all directions. It'll come back here to 4, but it goes to positive infinity. And again, your range, think of it as your y's. So now, the next part is this a function? So remember, when we talk about if it is a function, we're doing the vertical line test, VLT, vertical line test. That's where we start drawing vertical lines, and we start to see if our graph ever is intersected, or our equation is intersected at more than one point. No matter how I draw these vertical lines, you can see it's only hitting it at one point, one point, one point, one point. So since it's only one point, this one is a function. Again, when it's not a function, is when you get a graph that's kind of like sideways, and you intersect, and you get 2 points like that. That would be a not a function. All right, last but not least, is this discrete or continuous? Well, you can see that as I was graphing this, it kept on going in both directions with lines. So that is a continuous function. All right, last example. Ooh, we have a whole bunch of coordinates here. So I'm going to start graphing these coordinates one at a time. X is -3, then -5. 1, 2, 3, 4, 5. Put a point. -2, +4. 1, 2, 3, 4. 2, 1, 2, -3. 1, 2, 3. 4, 2, 1, 2, 3, 4. Up 2, 1, 2. And then the point 2, 1, 2, up 1, 2, 3. So my domain, again, is all of my x values. So we like to put them in order. So if I look, my first x value here is at -3, followed by -2. And then I have 2, and then 4. Even though 2 repeats itself, I do not repeat it in the domain. So then for my range, I'm looking at all the possible y values. So if I start here on my y at the negatives, I'm down here at -1, 2, 3, 4, 5, -5. Then I have -3, -5, -3. Then I have 2, 3, 4. And I have my range. So now, the question is this a function? So to check out if this is a function, I start doing vertical lines. Well, this vertical line only contains that point. This vertical line only contains that point. But this vertical line has 2 points. So since there's 2 points on that vertical line, this is not a function. Likewise, since you're given them as a set of points, and it's not given to you as an equation to like a curve or a line, this one is discrete. All right, that takes care of the review for 2.1. Study hard, and we hope you do well on your quiz.